Okay, so this is the second problem that might be of interest to you. And all I'm going to do here is um, do a transformation where I'm actually interested in what the stress state is if I turned my x-axis such that it was pointing off in this direction here. So not quite 90 degrees, but pretty much in that direction. So for some reason I want to work out what the stress is going off in that direction. So that will be my x dash, and my y dash will be perpendicular to that. Y dash, got perpendicular. Rightio. So what's the original stress state? What is the equations I'm going to use? I want to find out what the new stress state is um, in the x dash and the y dash, and also what will be the new shear stress dash. Okay, right. I'm gonna have that this is 60 megapascals, and although the y is pointing upwards, it's actually being in compression. So I will use that my arrow is pointing upwards, but a negative number, so a minus 70 megapascals. So first of all, when you think about what's happening here with our stress state, it's being pulled apart in this direction, squashed in this direction. When I in effect make my x almost point upwards, not quite, but almost point upwards, I now should expect that the new x is going to be roughly this number, because x will now be roughly pointing upwards, and that the new y will be going off in this direction. So this is going to be the same as this value. So the new y will be the previous x. Does that make sense? So all I'm kind of doing is I'm pretty much doing a 90 degrees turn, but not quite. So therefore I expect those two stress values to actually flip pretty much. And for the shear stress, I will have a positive 25 megapascals. And so if that's giving me a shear stress which is kind of making things go being pulled in that direction, if when I go off and do a 90 degrees rotation, I'm expecting it almost to be going in the opposite direction, so I'm expecting that to become pretty much a minus 25 when I do the rotation. So that is what I'm interested in doing, and I don't know how to do that. So what I do is I look it up on my formula sheet. So let's have a look at our formula sheet. So if you don't have one of these, you need to ask Arno for one, because this would be the sort of formula sheet that you're going to have if we were doing an exam. Right, so can we find where we're doing transformation? So we can see that we've got fetas here, got fetas here. Can you spot them? Hopefully not too difficult what equations we are actually going to use. So the equations going to use are these guys. All right, so now before we just plug in our numbers, so this is all we're really doing is plugging in the numbers into this set of formulae. Notice that we got repetition of certain terms. We're doing this quite a lot, and also this and this are kind of the same. This and this are kind of the same. There's swapping these terms here and here. So my advice would be to actually work out what some of these terms are. So work out what that is, work out what that is, and then when you drop down and use it for your next equation, you can then substitute in. So let's do that. So shall I put it here? So we're going to use this equation. I'm going to be a bit naughty and go left to right. I shouldn't really have two equal signs like that. So work out the first term here. So that will be my 60 plus a minus 70. Ooh, looks naughty. Divided by 2. So that's this term here. So we can put in minus 5. Now we can solve that one there. So that's going to be also minus 5 there. Do we use that here? No. And now let's work out this term here. So we've got 60, take away 70. So that would be plus 60 plus 70 divided by 2. So that would be plus 95 going in there. Right, so I've got a minus 95 going in there. And here we can see get a minus, so a minus 95 going in there. Actually, I want to take this term and multiply it by the sine 2 theta and this term by the cos 2 theta. Let's work them out then. So we can do this up here. Cos 2 theta equals my rotation is going actually it's going to go anti-clockwise. So I'm going in an anti-clockwise direction like that, and that will give me 88. So let's see what we get there. So cos 2 times 88. Now if we were going in a clockwise rotation, that would be a minus 88. So cos 2 times 88 equals minus 0.99. Whoops. 7564. So, where are we going to put that? Going to put that here. I'm going to pick 0 of this really. I'm going to put that here. And I'm going to put this down here. So we are going to have plus 25 minus 0.997564. Now let's work out the sine 2 theta. Okay, so that will be sine 2 times 88 equals sine 2 times 88. So 0.069 246. I'll do same amount of decimal places. 765. 756. Okay, so that goes here. Alrighty-o. And here we've got a plus 25 and a minus 25. And here we have the 0.069756. And here we have the 0.069756. Right, well, let's work out those numbers. The first one will be minus 5. And I'm going to save this on my calculator. 95 times by minus 0.997564 plus 25 times by 0.069756 equals minus 98. Looks like I've done something wrong. Maybe. Okay. Haven't got the 95 wrong, have I? 70. Let's write it down. I can rub it off. I've got it wrong. Minus 98047. So 60 plus 70. That looks wrong to me. 95. 2. Where did I get the 95 from? Maybe I'm going dyslexic. Okay. Did you spot my deliberate mistake? Yeah, of course you did. 6, 6, 6. And let's rub that off. And start again. Minus 5. And you notice that I did that deliberately because to demonstrate I was expecting the numbers to basically switch and they didn't. So that's always use your engineering brain. Times by minus 0.997564 plus 25 times 0.069756. What about now? So the x was 60 and that's become minus 68. Yeah, so it's kind of switched. Uh, 0.98 and that'll be megapascals. Right, so now I'm going to use the replay button and I'm going to replace my minus there. And looking for the 65 and the 65. We want to say take away 65. So that gives me 58. 0.098 megapascals. So Y was minus 70 and now it's roughly become 60 as we expect. So this final one, we expect it to flip sides pretty much and stay about 25-ish. So minus 65 times by 0.069756 plus 25 times by minus 0.99756. And what I'm going to do is I'm going to leave that error where I wrote 95 when I should have written 65 in, so everyone on YouTube can laugh at me, and so that you can send me an email. Go, oh, you got it wrong, you got it wrong, you got it wrong. Ah, you spotted your mistake at the end. Okay. You got to laugh, eh? 473 megapascals. Okay. So that's it, really. As I said, when you're doing the transformations, think about what are you expecting things to transform. So if this was, for example, we did a anti-clockwise rotation of, let's say, 30 degrees, we would pretty much expect maybe the 60 to stay the same-ish, probably not really, and the 70 to sort of stay the same-ish, or maybe a bit lower than 30, maybe 15. If it's 45, probably you can't really work it out in your head, but this particular case I had 88, pretty close to 90 degrees, so I knew what I was expecting to happen. Right, well, hopefully that might help you. Don't know.